streaming. Okay, excellent connection. This is streaming. Yes, let's go. So, by difference, I've seen this question. So I'll just go on ordered map and pool. I'll say #1 unordered map of endpoint pool #2 auto nums1 as #1 of num to true or auto nums #2 of true as well. Now I'll initialize vector of int to vector of int first of all as in 1. So not present in nums2 or auto num in nums1 if #2 dot find num related to #2 dot end. If we are unable to find it, we'll just do v1 dot push back num, and else we'll continue and again for auto num nums2 if #1 dot find num #1 dot end to the end, then we could push back num. Int solution of push even solution back if we do say return solution. Okay, understood multiples, right? And I just set #1 of equal false and #1 of num equal to true. Same over #2 of equal to false and #2 of num equal to true. So typo conflict duplicates. Hash for mixing array if hash dot find x hash dot end hash if it's true, else false. Count. Number of occurrences of each value. completely misunderstood the problem. The problem is find unique number of occurrences in the sense each number should have a unique frequency. Okay, so we could do this. Point frequency for auto x in ARR if frequency dot find, we got to just do this right, frequency of x as percentage initial as 0, then return frequency dot size, we go to ARR dot size. For auto element frequency, this is set int of frequencies, not frequencies, unique frequency, unique frequency dot insert element, say return unique frequency dot size to ARR dot size. I think that should work. Oh. Read out second. That is fine. That is fine for this input account. Swapping means both are the same. And so D, number of unique frequencies should be same, right? The number of unique frequencies should be same. So if word one dot size not equal to word size, return false, then I'll have an or int comma int hash one dot map hash two or dot com hash one of c plus hash of c plus plus equal to c return false. When I'm born. Okay, let's try and hash this. Plus equal. Rise. Sometimes I love you. What the hell? What the hell? Closest North Star. It's left. Let's remove the starts. Let's pass it removed. So let's yes. If C equal to star string solution is equal to just an empty string. Now to the top not equal to star star to the top history dot push C. Is not empty. Solution is equal to the top plus solution to the top. What the hell is Mhm. 10 minus 5. 10 just stable. The 2 stable. There's no copyright. Thank you.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve asteroid collision. So we're given an array of asteroids, and each asteroid is an integer, right? So if the asteroid is positive, that means the asteroid is moving to the right. If the asteroid is negative, that means it's moving to the left. So that makes sense so far. And the absolute value of the asteroid represents the size of it. And so basically each asteroid is moving at the exact same speed, and we'll see why that's important in a second. So there are a few rules for these asteroids. We want to find out the state of the asteroids after all collisions have been finished. And if any two asteroids meet each other, that means the smaller one is going to explode. So the smaller one is going to be removed from the array. If both of them are the exact same size, then both of them are going to explode, meaning both of them are going to be removed from the array. But how do we actually know if the asteroids are going to collide? Well, that's where the same speed comes in. So if one asteroid is moving to the right and another asteroid is moving to the left, then they're definitely going to collide. But if two asteroids are moving in the exact same direction, right? I have two asteroids, let's say, are both moving to the right. Since they're moving at the exact same speed, they're never going to collide, right? So it makes a little more sense when you actually look at an example. So let's say this is our example. We have a 5, a 10, and a -5. So what does this actually represent? Well, it means, so basically the 5 is positive, right? That means it's moving to the right, and the 5 represents that the size of this asteroid is 5. We also have a 10, and it's positive, so that means it's also moving to the right, but this one's 10, so it's actually a little bigger than this asteroid. But we have a -5 that comes right after it. So that -5 asteroid, since it's negative, means it's moving to the left. So what's going to happen with these asteroids? Are there going to be any collisions? Clearly, these two asteroids are about to collide, right? We don't really care what time they collide or anything like that. They're moving at the exact same speed in opposite directions towards each other, so they're going to collide. Now, which one of these is going to be destroyed? Which one's going to explode? Well, the magnitude of this is 5 and the magnitude of this is 10, right? So this one is going to be destroyed. This asteroid is going to be destroyed. So the remaining array is going to be 5 and 10, right? But what about 5 and 10? Are they ever going to collide with each other? Clearly, they're both moving to the right, so they're not going to collide with each other. So all in all, when you take a look at the output array, all we have to do is remove -5. So the output is going to be 5 and 10. So let's just try iterating through the array, right? Let's say this is our input array. Let's start at the leftmost spot and then just start iterating through it and deciding which asteroids we're going to keep and which ones are going to collide with each other. And you'll find that using a stack data structure is going to be the most optimal way to solve it. Let me show you why. So let's say we have the first one, -1, right? Clearly, this asteroid is moving to the left because it's negative. And think about it, any asteroid that comes after it, whether it's moving to the left or moving to the right, nothing is ever going to collide with this -1 now, right? Because all asteroids are moving at the same speed. This is the leftmost asteroid and it happens to be moving to the left. Nothing is ever going to collide with it now. Now, if it was moving to the right, it would be possible that another asteroid could be coming towards it, right? And in that case, there could be a collision. But in this case, there's just not a collision. Let's go ahead and add that to our stack now, right? -1 added to the stack. Next, let's look at 3. So this asteroid is moving to the right, right? And the most recent asteroid that we added was moving to the left. So clearly there's not going to be a collision between these two asteroids, right? So let's take this 3 and also add it to our stack. Now let's look at the next value 2. So the 2 is also moving to the right because it's positive. The previous asteroid was also moving to the right. So there's no need for a collision, right? So we can take this 2, add it to our stack. Now we get to another node that happens to be negative, and negative means it's moving to the left, right? Okay, what about the previous node that we just added? Let's look at the top of our stack, see what direction is that moving. Okay, it's 2. That means the 2 is moving to the right. So clearly there's going to be a collision now, right? These two asteroids are going to collide. So we're comparing 2 to -3, right? And really we want the absolute value of this, right? Which is going to be 3, right? Absolute value of -3 is equal to 3. So we compare this 2 with +3, right? So since 3 is greater than 2, that means the 3 is going to win, right? So that means we have to destroy 2. How are we going to destroy 2? How are we going to handle it with our code? Well, what we're going to do is take this +2 and remove it from our stack, meaning we're popping from the stack, right? We're popping from the top of the stack, which we know is an O of 1 operation. Okay, so based on that, now we're done, right? We can add the -3 to the top of the stack. Not quite, right? You have to remember the case. There could be multiple collisions, right? So this 2 has been removed, but what about this 3 that we added to the stack previously? Well, that 3 is moving to the right. The -3 is moving to the left. So actually these asteroids are going to collide as well. And in this case, the absolute value of -3 is equal to 3. And that's actually the asteroid that's going to collide with 3 as well, right? So 3 is equal. So what's going to happen when they're both equal? In that case, actually, that also means that this is in the case where the element we're adding, right, the asteroid happens to be negative, so asteroid is less than 0, and the top of our stack, which I'm going to call stack at index -1, is greater than 0, right? So if they're in opposite directions and the most recent one is negative and the top of the stack is positive, only then do we have a collision. Now the other case would be, we'd take 2 plus -3, we'd get an output of -1. What that means is that the negative asteroid is going to win, right? If we had +3 plus -3, then we get 0, right? That means both of the asteroids are going to be destroyed. Now, the other case would be, let's say hypothetically, this value in our input was a 4, a +4, which we didn't end up seeing. But if it was, we'd get 4 plus -3, which is going to be +1. And that means that the right asteroid is going to be destroyed, but the left asteroid is not going to be destroyed because this is positive, right? So that's what I'm going to be showing you how to do in the code. And the code is actually pretty simple once you understand how to use this stack. And by the way, since we're only adding an element and removing it from the stack once, right? So O of 1 plus O of 1, and we're doing that for every single element in the input array, which would be size n, the overall time complexity is going to be big O of n, and the memory complexity is going to be the exact same. Okay, so first thing we do is declare our stack, which is also going to be the result, right? Because the remaining asteroids are going to be returned. Then what we want to do is go through every single asteroid in the input, and then we want to start doing the collisions. But remember, we can only do collisions if the stack is non-empty, meaning there's a asteroid inside of the stack, and the current asteroid we're visiting is negative, meaning it's moving to the left, and the asteroid on the top of the stack is positive, meaning it's moving to the right. If all of these are true, that means we're definitely about to have a collision. Now, how do we know the result of the collision? Well, I'm going to store that in a variable diff. I'm going to take the asteroid A, add it to the asteroid at the top of the stack, right? And remember, if the diff or the asteroid's added together happens to be negative, that means the asteroid A is going to win. So what we can do is take the top of the stack and pop it. Now, if the diff was positive, meaning it's greater than 0, that means the top of the stack is going to win. That means A is going to be destroyed. So how can I basically accomplish destroying A? Well, I'm going to set it to 0 because they guarantee us that no asteroid in the input is going to be 0. So if I set this to 0, then we're definitely not going to add it to the stack. Later on, I'll show you why that's true. And if we set this to 0, this loop is going to stop executing, right? Because this condition is no longer going to be true. Now, the third case that you don't want to forget about, I always forget about it, is what if A is equal to the top of the stack? That means both are going to be destroyed. So what are we going to do? Well, we're going to do both of the things that we just did up here. We're going to set A to 0, and we're going to pop from the top of the stack. We're destroying both of the asteroids. And basically, once this loop is done executing, we have destroyed all the asteroids that we can so far. So what are we going to do? We're going to take A and append it to our stack, right? But remember, we could have possibly set A to 0. So if we did set it to 0, we want to make sure that there's a condition. So only if A is still positive or even negative, only then
While auto asteroid, okay. So nice.
are we going to add it to the stack?
Second ST or and E is smaller than M. And return ST dot top is greater than 0, right? And the difference is equal to A plus ST dot top. And the difference is smaller than 0. Is ST dot top is if difference equal to 0. ST top and the asteroid is equal to 0 is greater. If A is not equal to 0, then we just dot push and say done. What the hell? What the hilly? What the hell? Okay, this is how we build it. There's no alternative. What the hell? What the hell? So the difference is, first of all, is the coming asteroid is negative and the top is positive. Then there's an collision as there is not. Take out the difference. If the difference is zero, then the new asteroid is not there. And if it is already big, I think. Okay, this is a good question. Decode string. I don't know, man. These mediums are pretty hard for me. If we see a zero, then we just flip it into one, right? Until then, we shrink it, and this is a zero. And what's this? What is this? Full extreme dependency.
Hey everyone, welcome back and let's write some more Leetcode today. So today let's solve the problem decode string. This is different than the recent problem that we solved, which was encode and decode string. This is a much different problem, even though it has pretty much the exact same name. So in this case, we are given an encoded string based on certain rules, and we want to return the decoded string. So the main rule here is that we could have some text that basically fits this little pattern over here. K, basically K is going to represent some integer, and then we're going to have some brackets, and these brackets are going to contain some characters. So for example, we could have something like down here you see, right, we see a 2, and then we see a B, C. Basically what this means is that this integer over here, in this case 2, represents how many times we are going to repeat. But the difficult thing about this problem is that these brackets can actually be nested. Now there's always guaranteed to be an integer, right before a opening bracket, which is good. There's, all these input strings are going to be valid. So there's always going to be an integer before some brackets, and the brackets are always going to contain some character 2 because this 2 belongs to the next pair of brackets like this. So then how would you decode a string like this? And let's actually add the 3 at the beginning. So what does this tell us? This tells us 3. This 3 applies to everything that's inside of these brackets, right? So we want to multiply this string 3 times. How do we figure out this string? Well, we got to start with the first character A, and then we get to a 2, which belongs to this bracket. So you can see that we have a sub problem inside of the original problem. So you can think that this problem might lend itself to some kind of recursive solution. So now that we got into this 2 will represent basically this. So then we're going to go through inside of this bracket. We're going to see, okay, everything that's inside of here is a C. We get to the closing bracket. That means we're done with this sub problem, right? This evaluates to a C, but this C has to be multiplied twice. So then we're going to get 2, or basically C, and this 2, is done, right? We're done with that 2. And of course, at the beginning, we had the lowercase character A. So now the problem has changed into this, right? So it is. So this nested bracket is basically going to be the only complicated logic within this problem. And there's a couple solutions to actually solve it. So let's go over that and then we can go into the code. So like I said, the nested brackets is what's going to be what makes this problem difficult. So you can think that one possible way we can have nested brackets is, we have some outer brackets and then inside those we have one single nested bracket, and then inside that we have another nested bracket. What would kind of the decision tree or the subproblem tree look like? Well, of course, we'd have the original outer brackets on the outside, and then within that we have another subproblem, another nested brackets, and then another nested brackets, right? So to solve this outside problem, first we have to solve this problem, and to solve this problem, we would have to solve this problem. We could pop back up to here, solve that problem, and then we could pop back the structure, something like this one. So different nested 3 child nodes. So to solve this outer problem, we have to first solve this problem, and then we have to solve this problem, and then we don't really back up to. But as you might be able to tell, when you have problems with nested brackets or nested parentheses, usually a stack is very helpful, and that's actually the way I'm going to be solving this problem. You can do it recursively, or we can actually maintain a stack, which will kind of explicitly tell us, once we're done with a subproblem, where to pop back up to. Going character by character in the input string, and then just adding it to the stack. So we'd first see the 5. We'd recognize that, yes, it's a digit. We're pretty sure that there's probably going to be a upcoming opening bracket, but we're not going to do anything until there is. So then we're going to still adding it to the stack, but we're going to obviously recognize that we are inside of a subproblem now. Every opening bracket is guaranteed to be, followed by a closing bracket at some point. So we know case B, we add another digit closing bracket. We find it's not going to be applied to the original opening bracket. It's going to be this way until we get to the opening bracket, and this is the first one that's going to be pick that from our stack, right? We're going to start at the beginning of our stack, keep going this way until we get to the opening bracket. D, we can add that to something different. We're of course not going to take this closing bracket and add it to the stack, right? Because in our solution, we don't really care about the brackets. All we know now is we've just completed this bracket position, right? So everything that was inside of this bracket, how do we get everything that was inside? We know it's a CD. How do we get that? Well, we're going to go to the top of our stack, right? We're going to pop. We're going to pop every single character from the stack. So we're going to pop this lower.
आलो थोड्या वेळात उघडच आहे दार हा उघडच आहे फक्त ओढून घेतो
Case D, we're going to pop this lowercase c. So at this point, we've popped CD, and then we're going to pop this opening bracket, and that's going to be the last character.
हाँ ठीक है
We pop, right? Once we popped an opening bracket, we're done. We've gotten our string CD, right? And what do we want to do with this string CD? Well, we want to take whatever integer was before it in the brackets. It could have been a single digit integer like 6, or
आलो आलो हाँ
could even be a double digit integer like 54, but either way we want to get that integer. How are we going to get it? Well, at the top of our stack we just popped the opening bracket, so now we're going to keep popping characters from the top of our stack while the character happens to be a digit. How do we know if it's a digit? If it's between 0, 1, 2, all the way up until 9, right? If it's one of those 10 digits, then we can but then we're going to be popping it. So in this case we pop just a single 6 because the next character happens to be a lowercase b. That's not a digit, so we're basically going to say 6 multiplied by CD. So of course that's what's going to go in the output, and what we're actually going to do now is take this 6 CD and actually add it to the stack 6 times, right? We're basically going to take CD and add it 6 times over here. So I'm not actually going to draw that out because it's going to be very long, but I hope at this point you actually get the idea of what this algorithm is going to do. Let's just dry run through kind of the rest of it. So we finished this part, and we actually got to the second closing bracket now too, right? So we're not going to add this to our stack, but what are we going to do? We're going to basically keep popping everything from the stack until we get to the opening bracket that's over here, right? So once we've done that, we're going to have this entire thing. We're basically going to have this AB portion, and we're going to have this 6 CD portion, and then we popped all of that, and then to the left, we're going to find another integer. In this case, the integer is 54. So what we're going to do is take everything that's here, everything that we just popped, and multiply it by 54. What do I mean by everything? Well, this AB that we just popped is going to be multiplied by 54, and this 6 CD is also going to be multiplied by 4. So basically, if we had 6 CDs consecutively, so basically this entire string would now be multiplied by 54. That's right, by CD, and then we multiplied it by 54. So those operations on our stack, and then we could return that output string. So that is all for the XA joining all of those substrings. One is if the character is not a closing bracket, right? If it's not a closing bracket, then we can go ahead and just add that character to the stack. This is the most straightforward case. The more complicated case is going to be the else case where we do find a closing bracket. Now remember, there were two main phases of if we found a closing bracket. Well, of course, we're not going to add this closing bracket to the stack, but what we are going to do is start popping from the stack now. What we're trying to pop is the substring. So initially, we're going to set this substring empty. We're going to keep popping until we get to the opening popping from the stack now. What we're trying to pop is the substring. So initially we're going to set the substring empty. We're going to keep popping until we get to the opening bracket, right? We want to get the substring that was inside of this nested bracket. So while the top of the stack is not equal to the opening bracket, we're going to keep popping. Now, I'm allowed to say while not equal to the opening bracket because we're guaranteed to find some opening bracket, right? The stack is never going to become empty before we find an opening bracket. So we want to pop a character from the stack. But what do we want to actually do with this character? Well, we're just going to add it to that substring that we just declared up above. We're going to add it to the beginning of the substring, whatever the character we pop is, and we're going to keep doing that until we've gotten to the opening bracket. Once we're done with that, we will have our substring. And actually, we're going to do one more pop because we want to make sure that we actually do pop that opening bracket. So we'll have one more pop, and then after that, now we want to get the integer that came before that opening parenthesis, right? We want to get whatever k value was preceding those brackets. So we're going to do kind of a similar thing here. While in this case, we do want to make sure our stack is non-empty. So while stack is non-empty, and while the top of the stack happens to be a digit. In Python, the good thing is we can do this pretty easily. We can just check. There's actually a function for strings. We'll check if the string, this character, is a digit. And while that happens to be the case, we want to pop this digit. Of course, it's going to be in the form of a character, and we want to add it to that string that we just declared up above, that k string. We want to add this to the beginning because we want to make sure the order is preserved. So every time we pop a character, we're going to add it to the beginning of that k string. So then once this loop is done executing, we will have k, some integer. It could be a single digit, it could be double digit. Well, we wanted to take the substring and then append it to the stack k times, multiplied k times, appending this substring to the stack k times by just in Python, you can literally multiply a string, which makes things pretty easy for us. That's what we're doing here. And then once that is entirely finished, we are pretty much done with this loop. And then we can go ahead and return the solution. But remember, we can't just return the stack because the stack has a empty. They wanted it to be a output string. So that's what we're doing here. And that is the entire code. Now the time complexity is a little bit complicated to analyze because it's going to depend on what the input is, right? So on the left, you can see that yes, this solution works and it is efficient. So we know that it is an efficient solution. It's limited based on what the input is, right? So of course, in the input, we could have like a million, A, B, or whatever. That means we have to multiply this string a million times. So the output is going to depend on that. But this is about as good as you can get this algorithm. I would say it's a linear time algorithm. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot. And I'll hopefully see you pretty soon. Thanks.
Of string or auto C in S if C not equal to closing bracket, closing bracket, then I will just say st dot push C. I'll just do this in Python 3. This is easier. Just is equal to this thing for C string if C not equal to closing bracket, then this is stack dot append C else substring is equal to a non-string and value stack of -1 not equal to this thing substring is the stack of -1 substring -1 plus -1 plus substring stack of pop. How do you perform a pop? Stack of pop. So stack of pop again. Then while stack and stack minus cheat, right? Stack and stack -1 is digit. Okay, this thing AK plus is equal to stack of -1 plus K stack of pop and we just stack of push back of K star substring and just set it on join of stack elements. Let's go to Python. Parentheses are just tag, it seems. Okay, good. Where did I start? I started with 7. That is fine for now. Just have a lunch and let's go.